Okay, everyone, hello and welcome to the launch of the minimum design standard for building services in Abu Dhabi and the Kingdom of Saudi Arabia. Before we start, we have some simple housekeeping rules for the session. After the welcome, all speakers will turn their cameras off to maintain the bandwidth, and we request that the audience keep your cameras and microphones off. And if you have a question, please could you submit it through the messaging function and they will be answered during the Q&A session. So today we'll be hearing from FARAH Naz, the Chair of CIBSE UAE, Isaac Coker, who is the Technical Committee Chair, Alejandro Falcon Bonilla, the Social Secretary and Events Organizer, Drew Tinsley, Stephen Kelly, Pradosh Krishnamurthy, Mahmood Dabala, Giovanni Tucker, who's the Chair of SOFI UAE, and Imran Sheikh, who's the Vice Chair at CIBSE UAE. It's now my pleasure to hand over to FARAH, who will introduce the session today.
Good afternoon, everyone. Thank you for joining us today. Today is a very special day for all of us at the CIBSE UAE Committee and for the CIBSE UAE members in the region. So my name is FARAH Naz. I have the pleasure of chairing this wonderful committee. And today I open the session with so much gratefulness and graciousness to the entire committee and all the members who have supported us through this journey. So welcome to the event today, and I hope you find some meaningful information throughout the event. Can I hand it over to you, Elaine? No.
We're now welcoming Isaac, who will cover the objectives of the design guide.
Isaac, you're muted.
Good afternoon all. During the launch of the design guide for Dubai last year, we indicated that our next task was to work on the design guides for Abu Dhabi and the Kingdom of Saudi Arabia, respectively. As the chairperson of the technical committee, I'm pleased that with the assistance of the committee, we've been able to accomplish this in a timely manner. A big thank you to all my fellow committee members for their input. Also, on behalf of CIBSE UAE Committee, my humble gratitude to CIBSE HQ for their assistance, and more especially to Elaine Bell and Ken Butcher for editing these guides, which is very much appreciated. I will now give a quick overview of these guides. We have collated these minimum design guides for mechanical, electrical, public health services. There are two independent guides, one for Abu Dhabi and one for the Kingdom of Saudi Arabia. The guides have been written to assist new engineers going to work in each of these jurisdictions, building services professionals working in the jurisdictions, and also university students studying building services. We believe these design guides will contribute to the current sustainability design agenda being promoted in each of these jurisdictions. The guides will form the agenda for further discussion and inputs from local authorities, which will be incorporated in future revisions. I will finish off by kindly requesting that you review the guides and provide us with your constructive feedback. The email address to send your feedback will be displayed at the end of this presentation. I would now pass you over to the lead committee members to provide you a quick overview of the contents of each guide. Thank you.
Thank you very much, Isaac. My name is Alejandro Falcon, a technical committee member of the CIBSE UAE. Further to the launch of the CIBSE Mechanical Design Guide for Dubai last year, I'm pleased to introduce today to the CIBSE Mechanical Design Guide for Abu Dhabi. The guide elaborates on a similar content structure, as you can see on the right-hand side of the slide. But in this case, the guide approaches the design practice more from the perspective of the Abu Dhabi International Mechanical Code, the Abu Dhabi International Energy Conservation Code, Abu Dhabi Civil Defense Particular Requirements and Fire Safety Code, STIDAMA guidelines and the PEL rating system, Health Authority Abu Dhabi regulations for healthcare application. And these codes need to be seen in conjunction with international standards and guides of application in the Emirates, which can be CIBSE, NFPA, ASRE, etc. The guide highlights in the chapter or section Climate Zone and External Conditions the fact that the Abu Dhabi Emirate is divided into three main zones, which are Abu Dhabi itself, Al Ain or the Eastern region, Al Dafa or the Western region, for which the respective annual space cooling conditions at a 0.4 percentile, space heating condition at 99.6 percentile, and the dehumidification condition for fresh air equipment sizing are recommended for the various zones. It's worthy to point out that the guide mentions how the Abu Dhabi International Energy Conservation Code in its chapter 4 and 5 encouraged the mechanical designer to minimize the energy use by applying strategies such as variable frequency drivers in fans and pumps, high efficiency energy recovery systems in fresh energy units, demand control ventilation in spaces where the occupancy is 40 persons per 93 square meter and spaces larger than 50 square meter. And in general, set a low carbon footprint emission mindset in the designer. The guide also mentions how the Abu Dhabi International Mechanical Code instigated the designer in its section 1103 to use always zero ODP and low GWP refrigerants in the design that we do. Overall, the guide touches on all of the aspects of the mechanical design and provides key recommendation, documentation of reference, so the mechanical designer can set his basis of design in the project that he needs to design and deliver. Having reached to the end of my summary, I give way to my colleague Drew Tinsley to speak on the Abu Dhabi Electrical Guide. Thank you.
Drew, can I just ask that we delay 1 minute so I can admit some late coming delegates? Thank you.
No problem.
Bear with me.
No problem.
There we go.
Okay, hello, I'm Drew Tinsley. I did the presentation last year for the electrical portion of the Dubai guidelines, and I just wanted to reiterate some of the points that I made last year, particularly about people who, with this being quite a transient region, come to this locality, to the UAE, and find out quite quickly that there's a lot of different standards and guidelines that we need to adhere to. Those guidelines often change, and I think there's quite a lot of information that you're seeing on screen in terms of the content, but I think the key for me is always that the design codes, standards and guidance that we should be using specific to a particular area. Now in Abu Dhabi, there's some new guidelines for wiring regulations and supply, which were brought out in 2020 from the Department of Energy. And then much like Diva in Dubai, we have Addc regulations for the electrical distribution code, which has been around for quite a while now. So I think a lot of the people that work in Abu Dhabi are familiar with that code, but it also has a separate portion for the Al Ain region of Abu Dhabi also. Generally, these codes are sort of built on the back of BS 7671. Which obviously helps anybody that is familiar with the British standards, but there are definitely certain nuances, which I'll touch on shortly. In terms of designing for fire and life safety systems, the principal document is the Civil Defence Fire Code and the UAE Fire Code, which is underpinned from NFPA documents 70 and 101. What we have to be mindful of when you're working in this region is that is a lot different to a lot of parts of the world, particularly myself that came from the UK and working on projects in Europe, which don't tend to use essentially the American guides. And then much like BREEAM or LEED that we see globally, there's a different sort of energy rating system in the Astrodharma guidelines and the Pearl rating system that they use. So principally, those are the key items when it comes to design codes and standards that you really need to familiarize yourself with the project with the codes applicable to your project, and also the specific requirements when submitting information to local authorities of jurisdiction in the region that you're delivering, particularly Abu Dhabi, which I've found through experience has been often somewhat more challenging than projects that we have in Dubai. So I'm just going to pick up some key points in terms of income and services. The income and services are very similar, the 230 and 430 volt and 50 hertz, which is congruent with Dubai, and standard voltage drops of 4%. In terms of calculation and loads and diversity, that can be quite different in this part of the world, and particularly different between Abu Dhabi and Dubai. In terms of how we calculate load in the region, we use total connected load, but heavy diversity loadings can be applied to projects in Abu Dhabi when compared with Dubai. So it's particularly one that is heavily focused on when we're submitting things to Addc, that we need to be mindful of the specific point loadings for things like sockets and the wattages for sockets and the quantum of sockets that might sit on a single circuit. In terms of main distribution, there are certainly sort of 5 categories for connection: 2 at 400 volt, which would be internal and external user premises, and then 11 kV, 22 kV, and 33 kV as we move through medium to high voltage. In terms of equipment specifications, there's a lot of guidance in these guides that obviously draws the eyes to specification items for things like RMUs and switchgear, and which guidelines you should be using for those, which might be more international standards. So it really aims to assist the engineer in terms of where to find that information, and then standard things like ingress protection for MDBs and forms of minimum forms of construction, such as 4B type 6 for MDBs, etc. And then the nuances of DBs that might be rated over things like 200 amps, which require their own spaces as well. In terms of power factor correction, very much the same as the rest of the world, between a 0.9 minimum and unity maximum. In terms of standby generation, it tries to assist the engineer of giving a sort of shopping list of what you need to be mindful of that might need to be either a life safety system or potentially something that is used for a business continuity perspective, and really draws the eyes to what you need to maybe apply to your design and decide with your client whether that should be included in the backup system. And then some, again, nuances of Abu Dhabi and Dubai, which has things like 20% of the circulation lighting that needs to be on backup generators, which came from a circular a couple of years ago. In terms of lighting, you're kind of in safe hands. We'll follow the SLL guidelines and ASHRAE 90.1 in terms of lighting densities. So there's some guidance around that, and then also on lighting control, but the lighting control, I would say, is an international standard. Emergency lighting is slightly different. Obviously, that is a package of works that you will submit to Abu Dhabi Civil Defence, so using the appropriate fittings that are approved by Civil Defence before you even start is something that I just want to make clear, because that does catch engineers out. And then obviously using things like self-contained emergencies that we do internationally doesn't always work in this region. It might work on smaller scale projects, but generally the larger scale projects are backed up by central battery systems. Again, fire systems uses the UAE fire code, so just be mindful of that. The UAE fire code and more importantly in NFPA, doesn't really draw the eyes to a simple system of what you need to comply with. This guideline does give a little bit more guidance on that in terms of assistance. In terms of lightning protection, this follows the British standards, so not too much to catch people out, which is what we principally use internationally. And the same follows for earthing and bonding, with a couple of nuances of Abu Dhabi. Generally, that's all I want to draw the eyes to. We could talk a lot longer, but I'll pass on to Stephen Kelly, who'll cover the public health for Abu Dhabi. Thank you.
Thank you very much, Drew.
Then, Stephen, sorry, can I just ask that I'll admit some more delegates before we start, just to allow everyone to join. Right. Window. Perfect. Stephen, you should be able to see on screen now. Thank you.
Okay. Good evening, all. My name is Stephen Kelly. I'm a CIBSE Technical Committee member. It's my pleasure to introduce the Design Guide for Abu Dhabi, Minimum Design Standards for Public Health. The guide covers a systematic approach to design requirements for each of the contents indicated from 1 to 14, you can see on the screen. These are based predominantly on the unique codes to Abu Dhabi Emirate, which differ from, say, Dubai or Saudi Arabia, such as inside the guide, it will cover the Uniform Plumbing Code, Asadama requirements, and also the International Building Code of Abu Dhabi. The guide also covers different methodologies for calculating, say, drainage systems in compliance with both ADM and ADSSC, and including incorporation of food hygiene code requirements. Other points in the guide you will read are experiential, or often what are called the unwritten rules. So, such as when does a low-rise drainage system become a high-rise, and the impact this has on stack sizing, introduction of velocity breaks, and the guide also covers prohibitive practices that differ from, say, Saudi Arabia or Dubai, such as when are you permitted to install gas in basements, and in summary, the PH guide is there to assist you in the design of a compliant, well-engineered public health system hopefully for both new people to the region and as an aid memoir for veterans to Abu Dhabi design. Thank you. I'd like to hand over to Pradosh now.
Okay. Thank you, Stephen. So I've been a part of the technical committee, and I've been together with the team members. I've been able to put together the design standards for the mechanical services in the KSA region. The contents of the minimum design guidelines can be seen on the right side of the slide. As you may be aware, most of the design guides for the Saudi region were released in the year 2018. So any new construction and existing construction renovations would then have to adapt themselves to the latest guidelines from the Saudi Building Code. These are the local codes which are predominantly covered through SPC 501 for the mechanical services. And in addition to that, we have SPC 601 and 602, which relates to the minimum energy conservation procedures to be followed in the mechanical system design. Coming to the KSA climate zones, unlike UAE, KSA is a vast area and is predominantly distributed in 3 different climatic zones. The guidelines provide where each region falls, and there is a map which shows, depending on your project location, which climatic zone to be chosen. In addition to that, there's also guidance on what should be the external design temperature conditions to be considered depending on your project zone. While the SBC code particularly refers to the usage of 1% design conditions, the guidelines recommend to use 0.4 conditions predominantly to maximize the thermal comfort in case of temperatures falling outside that 1% region. There are also some minimum building fabric parameters, which are pretty much driven by the SBC 601 and 602 requirements. These dictate specific U values for the building envelope as well as for the glazing to be considered, depending on the type of construction for the building. With regards to the cooling load calculations, the calculations pretty much follow the principles of ASHRAE. Therefore, the future points with respect to the thermal loads and lighting power density, they also correlate to the information we are available through the ASHRAE fundamental guides as well as ASHRAE 90.1. For ventilation and infiltration, there are specific guidelines available under SPC 601, which basically is a recapture of the information available in ASHRAE 62.1 and 62.2. And for the infiltration rates, there are specific building pressurization requirements that need to be met. If you recall, in UAE, we have a specific standard value across for all the buildings, but in SBC codes, there are specific infiltration rates and building pressurization rates to be followed for doors, for walls, and for glazing. There are specific values to be adopted and specific delta pressures to be maintained for that design conditions. And for diversity and safety factor, the SBC codes do not specifically indicate to provide a safety factor, but it is the technical team's recommendation to consider at least 10% for the sensible and 5% for the latent heat loads. And diversity should be judged by the designer specifically. This depends on the project situations, operational scenario of the project, and that should be the basis to decide the diversity of the load factors to be considered. As I said, on the building pressurization system, there are specific requirements to be met, both for the walls, doors, and different elements of the building envelope. So those values should be considered and should be factored in the project design specifications. Under the air movement and noise and vibration control, these values pretty much follow the guidance provided in CIBSE and ASHRAE requirements. And under the energy conservation, these are standard energy conservation principles we follow for the mechanical system design. For example, being thermal usage of thermal wheels or heat pipes or runaround coils. And the cooling and refrigeration section, again, the refrigerants are to be limited to 0 ozone depletion potential and the global warming potential to be less than 100. Cooling tower sizing should be based on the worst case wet bulb conditions, and the approach should be at least 2.8 degrees C above the wet bulb condition in order to be CTI certified cooling towers. And the chiller energy efficiency is governed by a specific code of SPC, which cross-refers to usage of SASO codes, which is the CIBSE codes. And then the hydraulic pressures and temperatures are also dictated within the same guideline documents. For fire and life safety systems, there are no clear guidance of what particular life safety systems to be employed. Therefore, the designer is encouraged to reach out to the respective fire and life safety designers to propose the system suitable for it. In general, the code covers the requirements for stair pressurization, lift shaft pressurization, and also for atrium smoke vent. There is no reference to, for example, corridor pressurization system that we have in UAE. That has not been specifically cross-referred in the SPC code. Therefore, for the fire and life safety systems, the guidelines recommend that they need to reach out to the fire and life safety specialist to propose the appropriate systems for the building design. That generally covers the mechanical section of this guideline. Thank you very much. I'll hand over the vote to Mohammed.
Thanks, Vardosh. Good evening, everybody. My name is Mahmoud Derbala, CIBSE UAE Technical Committee member. Welcome, and hope the information we are just to impart on you will be beneficial. Generally, from the electrical point of view, we do have specific guides that we stick to during designing any project. So while we have the international standards, the focus should be on the local authorities' requirements and regulations. The CIBSE KSA electrical design standard guidelines focus on what are the local authorities' guides and requirements. And today I will touch base on the different document chapters and key points. So for chapter 1, which is the design codes, standards and guidance, the design of electrical projects in KSA shall be as per the SBC, which is the Saudi Building Code. For electrical, it is Saudi Building Code 401. And the KSA electrical local regulations documents can be classified into 4 categories. Like we have the first one, which is which is DPS, which is the Distribution Planning Standard, and DES, the Distribution Engineering Standards, and SDMS, which is the SEC Distribution Materials Specifications, and the last one, which is SDCS, the SEC Distribution Construction Standards. In Appendix 1, you could find the list of all of those documents and the title of each. Those documents are the mandatory documents that need to be used or shall be used during designing any project in KSA. In terms of incoming service, which is Chapter 2, it explains how services are brought to the building and the obvious stuff regarding the supply characteristics, medium voltage system, the 33 kV or 13.8 kV in Saudi Arabia, low voltage system, which is 400 volts 3-phase and 230 volts single phase, 60 hertz, which is the frequency in Saudi Arabia, fault level, power factor value, and the voltage drop limitation. So the section provides the information required on how supply characteristics are driven. In terms of load and diversity, which is Chapter 3, the electrical loads shall be assessed based on the individual site requirement, considering, of course, the local method of load assessment in accordance to the DBS, the Distribution Planning Standard Regulation for the volt ampere per meter square for each function or customer category, as Saudi Electrical Company used to call it. So DBS01 provide the volt ampere per meter square for each category that need to be considered in the load assessment stage. While the local means of load calculation should be used to establish the total connected load, the designer, of course, shall endeavor to incorporate the design solution to minimize the operational load and to reduce the overall energy consumption, considering the demand factors and constant factor, which is listed in DBS01 as well. The constant factor, which is the inverse of diversity factor, they call it like that in SEC documents. Chapter 4, which is main distribution. All distribution equipment, main distribution equipment, sub-main, and final distributions shall be arranged in accordance to SEC regulation and requirements, with particular consideration given to the location, equipment access clearance, distribution routes, and avoidance of having any wet services or areas above the or adjacent to the electrical spaces. For the equipment specification, the CIBSE KSA guidelines provide a brief about the electrical panel specification with reference to SEC document SDMS, and the recommendation for certain electrical values need to be followed in addition to the spare capacity, firm capacity for different electrical equipment. For power factor correction, as per Saudi Electrical Company and Co-Generation Regulatory Authority there, from May 2022, all designers should make a provision of installation of power factor correction capacitor banks to achieve a minimum of 0.95 power factor. So all designers right now need to consider that. And there's a certain document we are referring to within the KSA guidelines, CIBSE document, which is 43 SDMS 03, which provide the SEC material specification requirements regarding the power factor correction and the kilovar stages that shall be followed. In terms of surge protection, harmonics, and filtration, the document provides a brief about the consideration and recommendation and general understanding that will allow designers to design such elements in KSA projects. 4.6, which is metering. In terms of metering, the documents provide a brief about the different types of metering strategies and what are the Saudi Electrical Company documents that shall be followed, such as 32 SDMS, 38 SDMS, and all of that is listed in the Appendix 1 with the title of each document. Those regulations provide all mandatory details required to design a meter room from a spatial requirement perspective and meter rating that SEC, Saudi Electrical Company, usually use. Chapter 5, Section 5 of Chapter 5 covers the standby generation and distribution in a generic sense. It defines the key principles for standby generation in terms of fire and life safety with a high-level summary of equipment types, regulations, requirements for cables, ATS, the automatic transfer switch, and fuel tank capacity. Chapter 6, which is the UBS chapter, essentially is covered in the same way as the standby generation in terms of the system, location of UBSs, UBS requirements, and the redundancy configurations. Chapter 7 is for cabling, and this chapter aims to cover the SEC requirements, which sort of leans back on DBS 09 and DBS 10, SDMS 03, which showing the 13.8 kV and 33 kV medium voltage cable sizes recommended by SEC, and the maximum firm capacity of each cable. Also, it provides a brief about the low voltage cables, the single core parallel feeds for the main low voltage panels from the transformer, and for sub-main distribution, the essential cables that need to be used for the final circuits as well. And there's a table that summarizes the typical cable types that need to be followed by the designer as a guidance. Chapter 7.1 or section 7.1 from chapter 7, it provides a guidance on how cables should be contained. And there is a table, table 7.2 within the document, provide a summary on typical means of installation of containment system. Under chapter 8, the small power and power supplies, this is a generic principle on how small power and fixed power supplies should be arranged to suit the requirement of each installation. Taking into consideration the installation area, usage, and end user requirements. And this section lists a guidance for different domestic, commercial, industrial applications to cover the residential application, office areas, car park, circulation areas, and different MEP plant rooms. Chapter 9 covered the lighting design, which is generally linked to the CIBSE SLL guidance, showing all relevant consideration to design factors. From lux levels, uniformity, working plane, surface mounting height, reflectance values, maintenance factors, and all the related items to the maintenance factors, like the LMF, RSMF, LLMF, LSF. All of those items shall be considered while you are doing a project in KSA for the lighting stuff. Chapter 9.1 is for lighting control, and emergence lighting is chapter 9.2, and the document here provides a brief about the regulations that shall be followed, such as Saudi Fire Protection Building Code SBC 801 and NFPA 101. Emergency escape lighting design guidance are provided along with Saudi civil defense requirements for the backup duration, which is 90 minutes in KSA. And a brief about the emergency luminaire types and system types that also provided within the as a reference to Saudi Building Code for the requirement of recording and testing and circuiting requirements. Chapter 10 provides a brief about the consideration for the aviation obstruction lighting with reference to General Authority of Civil Aviation and International Civil Aviation Organization. Chapter 11, which is the lighting protection, the chapter within the document covered the or provide a brief about the lighting protection elements and design requirements, arrangement, and materials that can be used for projects in KSA. Chapter 12, which is the final chapter, and it provides a brief about the regulations that shall be followed for earthing system. Also, it touches base on the earthing and bonding elements that will help any designer to cover the earthing design for different electrical equipment within the project. I'm sure the Appendix 1 is really important for all designers because it had the list of all mandatory documents that need to be followed for designing any project in KSA. And that's it. Thanks for your attendance and your time, and I will hand over now to Giovanni for Public Health Service. Thank you.
Thank you, Mahmoud. Hi, everyone. So good afternoon, everyone. My name is Giovanni Toko. I'm part of the CIBSE Technical Committee member. I'm also the SOFI UAE Chair. In terms of content, the guide is very much similar to the guideline from Dubai and Abu Dhabi. It follows pretty much the same template, format, and outline. The aim really here is really to provide kind of a standard public health design approach from project to project, from region to region as well, and particularly based on local requirement and code in Saudi Arabia. So in terms of content, item 1, we talk about design code and standard guidance as well. Here in Saudi, so the local code is based on SBC, in particularly SBC 701 and 702 for plumbing and sanitary drainage system, but the guide also make reference to other relevant code in the region, like IPC and other BS standard as well. Item 2, we talk about local green building requirement. So the local green building requirement is defined by a set of documentation, which is the Mustadam. And again, it's pretty much fairly similar to what we do in Dubai and Abu Dhabi, like the Dubai Green Building or the Al Safat requirement or Estidama in Abu Dhabi as well. It's pretty much follow the same principle. Then we talk a bit about a bit more specific about the different services, domestic cold water services, for instance, water storage capacity and design criteria. And here, water storage capacity is defined by the MIWA standard, where we pretty much give you some guidance in terms of storage figures for different types of building and facilities as well. I won't dwell too much on the different system, public health system. It's pretty much standard, similar to Dubai and Abu Dhabi. Lesion control potentially is something which is very important to public health engineers. And again, this follows the same international standard as approved Code of Practice L8. The other services that I wanted to kind of pick already is a stormwater design consideration in Saudi Arabia. As some of you know, the Saudi climatic condition varies from region to region. So what the guide pretty much endeavor to deliver is to provide some guidance with different rainfall intensity IDF curve for key areas like Jeddah, Riyadh stormwater, and the Tabuk region as well, where potentially there's loss of development happening in those region. In terms of fuel gas, again, fairly standard approach to what we do in Dubai and Abu Dhabi. I won't dwell too much on that. So in a nutshell, really, that's kind of a very high level content of the different public health services that we've considered for the KSA design guide. So I'm happy to take more specific question in the Q&A session. That's really it for me. I'll hand over now to Imran.
Thanks, Giovanni. Hi, good evening, everyone. I'm Imran Sheikh, Vice Chair of CIBSE UAE. Just to provide a quick recap for the presentation till now for the attendees who joined in late. All the principal contributors provided a quick overview of the contents of the MEP minimum design guidelines, both for Abu Dhabi and KSA. Now we have reached the question and answer session of the presentation, which will be moderated by myself. So I would request the audience to send all questions through the messaging function, and we'll try to answer as many questions as possible. Please keep the questions general and specific. Given the time constraints, we'll not be addressing in-depth technical questions or discussions in this forum. However, all such questions and queries related to the guidelines, feedback, or additional information which you would like to be included in the guidelines can be sent via email to uae@cibse.org, which will be displayed in the last slide as well. And these questions will be forwarded to the committee for their in-depth review and response. So while we wait for the questions, the first general question which I've got from the other forum, and I would divert this to ISAC. What role or value do you see CIBSE minimum design guides will add in the region? And are these guidelines applicable for all project types? ISAC?
Thank you very much, Imran. I think the whole idea, and I'll pick on two of the overview comments I made. I think some of us, I take my own personal experience when I arrived from UK here about just over 12 years ago. It was very difficult trying to find information. So you arrive here with your experience from UK, and you have to contact friends, colleagues to try and get what are the nuances even between Abu Dhabi and Dubai. So to answer your question direct, we believe that this guide will help newcomers coming into the region to find the basic information under one booklet. The other thing is that sometimes, as we know, you do a design and you go through a peer review. This document has now been edited by CIBSE HQ. And we know that CIBSE is a well-recognized institution. And during the process of them editing this, they went through this to ensure that all the information there has been validated. So this becomes like a reference whereby when doing the peer review, there is any misunderstanding, that can be, this guys can be the reference point for it. I also will add that this will also bring consistency in the way we do things, because when you got the standards, then in terms, so it casts weight. So the sustainability agenda being promoted in most of these jurisdictions, we believe this will contribute to that. Thank you.
Thanks, Isaac. The next question is for Alejandro. And the question is, what is the recommendation for the external ambient condition for air conditioning and fresh air calculations for Abu Dhabi coastal areas?
Yes, what we mentioned there is whatever areas you have there, you need to use the dehumidification condition of the region. You may actually find in the chapter 14 of the ASA Fundamental, which is the reference that we are using in the guide for Abu Dhabi, particular meteorological locations based on airport database. So the recommendation I would do on this aspect is to just choose the closer to your location, and always choose dehumidification condition, which you can also explore and perhaps check with any other high latent value in the monthly breakdown of the weather data. And you can just cross-check which one is giving you the highest enthalpy and moisture ratio to ensure you actually size your coils properly and they don't fall undersized. I hope that responds the query.
Yeah, thanks, Alejandro. Just to add on that, coastal areas are always tricky, where the wet bulb is generally higher than the inland region. So it's very important to check the enthalpy differences and select the conditions accordingly in coordination with the local authority guidelines. Okay, so the next question is for Drew. What are the key differences between Addc and Diva guidelines, which the designer need to keep in mind for designing a project in Abu Dhabi? Drew?
Yep, I'm here. Yeah, so I think for me the challenges that we or I faced when I first came here about 7 years ago was a lot of the projects would be very different in terms of how they're submitted to local authorities, which I think is one thing. And then also essentially how loads would be calculated. I think the differences in terms of loads is in Dubai, obviously we apply certain diversities, a lot of those very similar to CIBSE guidance and to ASHRAE guidance when we're doing load diversity. But in Abu Dhabi, the application of load as we come further down, so when we're not looking at distribution board schedule level of 200 watts a socket, but when we're looking at applying diversity at later levels, there is a modicum of success to be had with projects in Abu Dhabi in terms of how the supply might be connected, not fundamentally having to use 1500 kVA transformers, potentially being able to use a higher capacity of transformer, and also being able to reduce the diversities a lot more heavily as we get back to the income and supply. Some of the ones that I would say that catch engineers out, I mentioned about distribution boards being over a certain amperage, about 200 amps. A lot of the time, that could be an MCP or something like that, and we would put them, let's say, into our plant rooms or in locations where they were sort of standing free in an area that in anywhere else in the world would be accepted. So I think one of the key challenges, and which you generally only find out once you've submitted your drawings to Addc, is that you'll ascertain comments from those guys that are reviewing your drawings, and then you'll have to start changing things from an architectural perspective, and then that's when you would get sort of clients on your case and that kind of thing. So I think a lot of the principles, you know, getting down to the local authorities and agreeing the diversities, agreeing certain strategies whilst your project's still in design, I think is a lot more it's a lot more resistive in Abu Dhabi than it is in Dubai, and sometimes it isn't as easy to access the local authority. The other thing is obviously the submission of your drawings. You effectively would submit as a designer through the Diva portal these days, whereas obviously in a lot of circumstances in Abu Dhabi projects, they would be submitted through the contractor. So unless you're in you know, a design and build contractual situation, you would be have almost have tendered your job, have IFC drawings, and your contracts team would be submitting those. So you lay yourself levy at opportunities for claim in terms of your design as well. So I think there's some of the key fundamentals. I think a lot of the guides follow the principles of Dubai, particularly when it comes to fire and life safety. And I think that answers the question. Maybe I went a little bit too far.
No, it does. Thanks for that too. Okay, so the next one is for Stephen. It's related to Abu Dhabi water tank sizing. So the question is the combined water and fire tank acceptable in Abu Dhabi? What is a good practice for water storage design, combined tanks or dedicated tanks for fire and water?
It's a good question. Now, I'm going to say unfortunately, combined fire and water tanks are acceptable. However, if you read the regulations, they actually state if the amount of fire water is excessive in comparison to the domestic water. So, for instance, if there's far more fire water than domestic water, they actually tell you in the RSB guide that it's prohibited to combine the tanks because essentially you're going to have a long turnover. So it is allowed in Abu Dhabi up until the point where the fire water exceeds a set value and becomes the majority of the water in the tank. At that point, they actually tell you then not to combine them. Now, I'd always not combine the fire tank and the domestic water tank just for turnover. And the other things you'll find with a fire water tank is you'll end up having the firefighting. You'll have the firefighting connections, which obviously won't be RAS or NSF approved. They'll be ULFM compliant. You may have the diesel pump pressure relief line going back into the tank. You may get test lines going back into the tank. So all of these things will essentially make your tank non-potable if you're not careful. So when they do get combined, and I'm not a fan of it, any lines which come off the pumps, test lines, pressure relief lines, I'd recommend they go to drain or to a non-potable tank like an irrigation tank.
Okay, thanks for that, Stephen. Okay, so moving on to the next question. I believe this one is for Pradosh. Which is the preferred standalone central plant solution in Saudi Arabia? Is it water-cooled or air-cooled chillers?
Okay.
Pradosh?
Yeah. Hi. Yeah. So to talk from an SBC code perspective, there is no particular reference to usage of whether it needs to be a water-cooled or an air-cooled device. It's left to the designer's choice to propose the appropriate system for the project. But from experience in working in few regions within the KSA, majority of the spaces in KSA have hot and dry. And then the diurnal temperature differences between the daytime and evening time is significant. So if you were to choose an air-cooled device, you could take advantage of improved efficiencies during the evening time, as well as the hot period is only for about 2 to 3 months. Rest of the time, the temperatures are quite within lower values in comparison to what we experience in UAE. There are also regions in KSA where the overall outdoor temperature itself is not significant. They are at less than 40 degrees Celsius in some regions. These are referred in the climatic zones within the SPC code, and it's also available in the minimum guidelines. So the choice of the proper appropriate design, whether it is water cool or air cool, is really left to the designer and not dictated by the SPC code requirements.
Thanks for that, Pradosh. And I believe, like in some of the holy cities like Makkah and Medina, where the water is like quite precious, it is, if you have to go with a water cooled solution, then it has to be treated water, TSE water, and then you'll need a polishing plant as well. So all of those factors needs to be considered before selecting that system, like Pradosh mentioned. Okay, so next one is for, I believe this one is for Mahmoud. What is the client diversity criteria used in KSA projects, and which standard need to be referred for the same?
Good evening, everyone. So basically, the diversity factor is listed in as DBS, the distribution planning standard, and all the diversity factor are there based on the functions or customer category, as SEC used to call it. So we have the diversity factor and demand factor that need to be used based on the area and the volt ampere per meter square that you will use to obtain the total connected load. The demand factor and constant factor used in SEC is basically it is following the AECOM and bridge standard. So you will find it there listed down clearly, and you need to use it while you are applying for the authority submission, and need to be followed in detail, because Saudi authority guys, they are checking it one by one based on the area that you have, the total connected load, and the constant demand load that you will have it based on the diverse factors listed in DBS 01.
Okay, thanks, Mahmoud. Next one is for Giovanni. Is a grey water treatment system widely used in KSA projects? Is that design criteria covered in the guidebook?
Sorry, can you repeat again? Is it we're talking about the wastewater design criteria, you said, yeah?
Yeah, so the grey water treatment system or the wastewater treatment system.
Yeah,
is it widely used on projects in KSA?
I would say yes, especially because of the scarcity of water, and again, we need to follow the overall sustainability strategy of any specific project. But for an overall water balance strategy, of course, is something that as a PH engineer we will need to and put more emphasis on. But to answer the question, yes, it's widely used in KSA, and again, you need to kind of speak to your local supplier in terms of the speciality of it, in terms of parameters, etc. But yeah, it's something that we should really consider, and it's kind of highlighted in the design guide as well.
Okay, thanks for that, Giovanni. I think looking at the chat, there are some issues with downloading the guides. Ella, I don't know if you are looking at the chat and if you can advise.
I've noted which one there are issues with. I will speak to my colleague who's uploaded them, Eileen, shortly after the meeting, and we'll see if we can circulate the link. Apologies for any inconvenience.
What we did was to try and I did ask them to upload it earlier this morning, so that gives them time for people, if there were any glitches, for them to fix it. If you can have a look at that for us, thank you.
We will.
All right, there is a question which has come up from Vikas. What are the major design criteria for sewage and storm drainage sump? I don't know if Stefan or Giovanni wants to just quickly highlight the key points for that. Stefan?
Sorry, he's on mute, so if I may just chip in.
I'm off mute, Gio. You can chip in and I'll chip in afterwards.
So in terms of foul water drainage system, it's basically what we do in terms of sump pit sizing. So what we need to do pretty much define in terms of your load estimate as well, and then to do with what's happening in terms of your pump capacity, in terms of treatment, etc. But having said that, the code, we don't really go into in terms of specific in terms of STP design. Yeah, so STP design is pretty much kind of a specialist design element that we don't really tend to get into. We can normally provide kind of performance specification for big STP treatment requirement, but normally what we tend to do is to provide the loads to a specialist, and then we'll take it from there really in terms of STP.
There's one more thing I'd like to add when it comes to the sewage sump pits or the stormwater sump pits. Often you'll find that you're putting these sump pits in or tanks in. Sometimes it's because of the infrastructure. So if the infrastructure has got limited capacity for the free discharge of stormwater or sewage, you'll have to calculate, as Giovanni said, what the load is coming from the building, what the load is available on the network, and provide some sort of attenuation or storage within the sump to allow you to pump out at a controlled flow, which doesn't obviously surcharge the network.
Okay, thanks for that. While you're speaking, Stefan, there's another one which has come in. Is wastewater treatment plant design guidelines are included in the guide?
So in terms of some of these sort of very specific types of design guidance, so things like wastewater treatment or reverse osmosis or ultrafiltration or solar thermal design systems, as the minimum design guide, you won't get these specific processes in the guide. So some of these items you won't find in there. You'll have within the design guide how to design the system to be one stack or a two stack system or a three stack system, which allows you to separate the foul and waste in the building and how to calculate the pipe sizing. But when it comes to designing a waste treatment system, maybe that's for another day.
Okay, thanks for that. Coming back to ISEC, there's a question here. What are the key mechanical and I think you've touched on it before as well, but if you can quickly reiterate your answer. What are the key mechanical, electrical, and public health challenges faced in the KSA region, and how CIBSE Technical Committee will be addressing this after the launch of this guide?
I think like all these things, what we are encouraging the audience to do is to review it and give us a constructive feedback on what are the challenges, because my understanding of the KSA is that each region has got its own kind of nuances in terms of how things are to be done. The whole idea of this, one of the objectives of this guide is every year we are going to review based on the comments we receive, the feedback, and then liaise with CIBSE HQ to update them accordingly. So again, it depends on the feedback we get. We as the committee will review it, and where we think is appropriate will be included. I hope that answers your question.
Yeah. I've got two more questions and then we'll be wrapping up the Q&A session. I see there's some details in the chats coming in pertaining to the information in the guide. Please feel free to send those questions and feedback via email, and then our team will get back to you. So coming back to Pradosh, what is the recommended space heating strategy for the KSA region, specifically for cities in Zone 2? Pradosh?
Yeah, right. So again, referring back to any of the guidance provided in SPC, there is no particular reference to usage of any systems for space heating. It is the designer's choice whether to use, for example, an electric duct heater, or could be with the LTHW coils in both the air conditioning and fresh air handling units. The choice is left to the designer. The assessment of the heating needs to be done appropriately, taking into consideration the factors like the building envelope, and also consider like minimum lighting and equipment gains to the space, which would what normally dictate what the heating loads for the space are. And having said that, whether it is economically viable to have a boiler-based system providing LTHW, or whether it is prudent to use an electric-based system, it all depends on the system load capacities. There have been situations where like there are 10 to 15 rooms which have exposure to the building envelope, and that for that amount of load, it wasn't prudent to provide a central heating system using boiler or with heat pumps to provide, to the LTHW coverage. In that situation, we would have used an electric heater. So this, again, the exact requirement needs to be reviewed by the designer based on a particular project specification. It cannot be a generic answer for a Zone 2 area in KSA.
Thanks for that, Pradosh. So the last question again is back to Isaac. What is the outlook of CIBSE Technical Committee for 2021-2022? Will the minimum guides for other regions will be released?
Yeah, the plan is also that we are going to review our objectives for the year, and hopefully tackle some of the other Emirates, all right, and also look at some of the GCC countries such as Qatar. We have been fortunate that about 4 years ago we became a chapter. So our aim is to reach out to the other GCC countries where CIBSE members are and assist them to, So CIBSE members who are on the call now, please reach out through the email address, which will be displayed at the end of this presentation, and let us know what you can do, and we will also be able to assist you to put some of these guides together. Because obviously you live in that particular country or region or jurisdiction, you know how you do things there, and we here will be able to support you to bring this to fruition. Thank you.
Thanks, Isaac. With that, I would wrap up the question and answer session. I still see there are more questions popping up in the chat. Feel free to send those questions via the email, which will be displayed in the next few slides. With this, I'll hand over to FARAH to take through the membership grades and close out the event. FARAH, over to you.
Reed, are you on the call? I was just thinking if Reed is on the call, he's our membership officer. Rezen, can you make Reed unmute if he's on the call?
Yeah, just give me 2 seconds.
Yes. So Reed Donovan, our past chair, heads up our membership, and I thought it would, if he's on the call, so I think it would be good if he gives you a bit of overview. Rezen, if you could please make Reed unmute.
Reed, you should be able to now unmute yourself and turn on your camera.
Hi guys, how you doing?
Hi Reed, we can hear you. I thought it would be good if you could just give everyone a bit of overview of what's happening on the membership side. Thank you.
Sure, okay, no worries. So thank you, Farah, and thank you for the presentation, guys. It's fantastic to see those further guides published. It's amazing work to everyone involved. I know how much hard work goes into those, so Well done, everybody. Yeah, my current role is helping people for their membership. First and foremost, if you need assistance, there's an email address there on the screen. You simply email your wants and needs for assistance with CIBSE membership or indeed chartered status, and then the emails are collated and then sent through to me. And as soon as I get time, I normally react fairly quickly. I can send you, anyone that needs the information, I can send you a communication that gives everything you need to progress your membership. And then obviously if you've got any further questions beyond there, you've then got a link with me, because you've then got my work email address, and then you can, I can help you through the process as much as possible. So please don't be shy. Most people have got similar questions. It's not a complicated process at all. There are some stages that we need to go through together to make sure that you're on the right track. But as I say, reach out to me in the first instance. To be honest with you, all the information is available on the CIBSE website, in the portal. It's everything you need is there. So, but if you're having trouble understanding some of the the processes, it's not an issue. Come back through the email address below, and I'll be able to take you through that in more detail. Just as some figures, I was just counting this morning, FARAH, actually. I was just going through my filing system here on my C drive. So in the last 12 months, we've supported about 40 people through either CIBSE membership or full chartership. So, it's great to see. I think the numbers of people that are gaining interest and reaching out is increasing. I get about 2 or 3, maybe 1 or 2 inquiries a week that come through. Also, what I would say finally is that, from my experience, is a number of people think that they're not ready, or they haven't got the right qualifications to become a CIBSE member. There's obviously on the screen on the left there's different grades. So, not everyone's going to come in straight into full membership and then become a chartered engineer. It doesn't always work that way. There are levels, there are stages to go through. But there are many people with many years experience that maybe feel they haven't got the right credentials in terms of their qualifications and their academic degrees and stuff. It doesn't mean you can't be a chartered engineer. There are routes through this. I've mentored a number of people that perhaps were a bit like me. They've got grey hair and they have to wear their glasses to read stuff. But they back in the day when they were like in their 20s and 30s, they didn't do a degree because it just wasn't the thing to do then. But they've got 40 years, 30 years experience. So CIBSE welcome those sorts of people, into the chartered world. And there's routes for membership, and then obviously charter status that comes on the back of that for that as well. So many people have approached me, and their first impression is, I can't become a chartered engineer. 70% of those people that said that to me in the first call become a chartered engineer. So don't be shy, guys. Just come forward, and we're here to assist you for the process. Okay. Anything else I should mention, FARAH, do you think, or that's probably enough? I would say.
No, thank you. Sorry, I put you in the spot.
No,
I
it's
thought
fine.
if you were on the call, it would be good.
It happens at least 5 times a day anyway. It's fine.
But
Thanks,
thank you,
guys.
Reid. Thank you, Reid, for the update. And I would really urge and echo what Reid just said. Please do reach out to us. We're open for conversation, and really quite encouraging to see that all these people have reached out, and we are seeing quite a bit of progress and interest. And also, if you are a member of a different organization and if you want to look in the fellowship route, please do reach out to me and Reid and the committee members. Roisin, it would be good if someone talks through the global what's happening in CIBSE.
Yeah, so I'm Roisin, for anyone who hasn't seen me before at these things. I'm the head of member services at CIBSE. I'll just give you a real whistle-stop tour as to kind of what the regions are for CIBSE, a little bit about transferring CEng if you're in different countries or you have a different institutional membership already, and some bits and pieces like that. So apologies if you already know all of this information and you've been a CIBSE member a long time and know more than I do potentially. We have about 20,000 members worldwide across, at last count, 93 countries, which is fantastic. And just over half of those 20,000 do hold Engineering Council registration in the UK through CIBSE, which is all fantastic news. We want to obviously push those numbers up, but we do have student members and graduate members, etc., that don't have that eligibility just yet. So we have international formal regions in the UAE, obviously, as you're seeing today, but also in Hong Kong, Australia and New Zealand. A region consists of a local steering committee and some administrative support, and it enables members in the region to have events that cover local, maybe countrywide or region-wide, but also international topics. In addition to those formal regions, we also have some smaller chapters in countries such as Singapore and Canada. These international regions are really integral to the makeup of CIBSE. They provide tangible benefits to our members, especially those outside the UK who may have felt that, because they can't attend an event in the UK, or some of our guidance is quite UK specific, an event like this really does provide that kind of global outlook that we're looking for here at CIBSE. Not only that, but it also does provide an extra benefit to UK members, which I think people don't appreciate often enough, possibly. We get different perspective from members who are living in different countries on guidance and consultations, and also gives us a wealth of case studies on projects that we wouldn't usually see in the UK as well, due to different client types, climate, terrain, etc. And we particularly see that the Young Engineers Network really appreciate them and have inspired some as well to move jobs abroad, emigrate, etc. I was also asked to touch just really briefly on transferring your chartership. As a general rule, although there may be exceptions, if you hold chartership through CIBSE, you can transfer your membership status to another institution and keep your CEng. So for example, some of you may be ASHRAE members, but maybe not a CIBSE member. We have a mutual recognition agreement with ASHRAE so that you can get the same. If you're a member of ASHRAE, you can be a member of CIBSE and keep the same level depending on whether you're chartered or not. So if you're a member of CIBSE, you would be a member of ASHRAE. If you're a member of ASHRAE but without professional engineering registration, you'd be a licentiate member of CIBSE. But if you did have professional engineering registration through them, you would also be a member of CIBSE, not a licentiate. I realise that this can get quite complicated and that everyone's situation can be different. So if you'd like some advice on that, by all means, email membership@cibse.org. I used ASHRAE as an example, but we also have them with Engineers Ireland, with Australia, New Zealand, Hong Kong, etc. So please don't hesitate to get in touch. Like Reid said, you can contact him, you can contact us. There's various routes and we're here to support. Just looking at the slide that's there in front of me, I'd like to say we've got lots of benefits of membership, but in particular, if you've got an engineering field that sits within one of our societies, there's a whole host of other range of benefits that they produce, specific journals, events, guidance as well. So I'd really encourage you to have a look at that if you're a public health engineer, which it sounds like on the call quite a few of you are. I would definitely have a look at SOFI membership as well. I also look after all the special interest groups as well as the regions and the societies. So kind of a one-stop shop. I will drop my email as well in the message board so that if anybody has a question about any of those things I've touched on that weren't specifically related to CEng or membership, then you can contact me about the societies, regions, Young Engineers Networks or special interest groups. Thanks, Farah.
Thank you, Rosen. And from CIBSE UAE side, please, we do have a very active LinkedIn and Twitter, and we also are active on YouTube. So please follow us and watch our previous conferences and programs that we have, because it's quite educative. And we also have combined information with REBA on our YouTube channel as well. And also last year we held 2 big conferences. One was on healthy building and the other was on net zero. This year we are also planning to hold student design competition and conference as well. So please look out on our all social media channels, especially LinkedIn, for updates. That's all from me. So if there's not anything else, I just wanted to reach out to everyone and say thank you so much for being with us. I know that there are some of you are having issues with the guides and downloading them, but it will get sorted in the next 24 hours. So please do log back on the website to have a look. And thank you so much for being with us today. And thank you to all the committee members, especially Isaac and the reviewers and the authors for your contribution, and CIBSE HQ for your contribution as well and support. Thank you so much and have a good evening.